Hello student. In previous video lecture we have seen that the concept of random variable, discrete random variable, probability mass function and probability distribution. Now I am going to explain the concept of cumulative distribution function or distribution function. The definition of distribution function is as let capital X be a discrete random variable taking values x1 x2 dash 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 xi dash 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 xn with probabilities p1 p2 pi pn respectively. Then cumulative distribution function. Cumulative distribution function CDF is denoted by capital F of x and defined as follows. Capital F of x is equal to probability of x is less than or equal to small x. Here x lies between minus infinity to plus infinity. In particular, f of xi is equal to probability of x is less than or equal to xi, which is equal to summation of pj summation over j running from 1 to I. Here I takes values 1 2 dash 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 up to n. This is the definition of cumulative distribution function. In tabular form, suppose the random variable x takes values x1, x2, so on, xi, again so on, xn, with probabilities p of x, p1, p2, pi, pn. Then distribution function CDF or DF. The probability at x equal to x1, which is p1 as it is. Then probability at x equal to x2 is P2, then capital F of x at x2 is P1 plus P2, and capital F of x at xi is P1 plus P2 plus so on plus Pi, and distribution function at x equal to xn is P1 plus P2 plus dash 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 plus Pi plus Pn. In this way we can compute the distribution function or cumulative distribution function. For example, we have a probability distribution. The random variable x takes values 1, 2, 3, 4, 5 with corresponding probabilities p of x at x equal to 1, probability 0.1, at x equal to 2, probability 0.2, at x equal to 3, probability 0.3, at x equal to 4, probability is 0.2, and at x equal to 5 the probability is 0.2. Now we have to find out the distribution function for the given probability distribution. Then by definition of distribution function we can compute capital F of x as capital F of x at x equal to 1 is 0.1, at x equal to 2 is 0.3, at x equal to 3 is 0.6, 0.8 and 1. That is, this is the cumulative addition of the p of x. Then we get the cumulative distribution function CDF, or it is also called as the distribution function only. We add these probabilities cumulatively, we get capital F of x. Now we draw graph of the capital F of x. Direct x-axis and y-axis. Take values of random variable on x-axis and on y-axis capital F of x. The values of random variable x are 1, 2, 3, 4, 5, and on the y-axis values of the capital F of x. 0.1, 0.3, 0.5, 0.7, 0.9, here it's 0.11. Now at x equal to 1, the capital F of x is equal to 0.1. okay, now the function in between 0 to 1, it is constant, and at x equal to 1 the function changes, and at x equal to 1 the capital F of x is equal to 0.1, this point. From 1 to 2 the function is constant, and at 2 the function changes at x equal to 2, the distribution function is 0.3. This point from 2 to 3, function is constant. At x equal to 3, the function changes. At x equal to 3, the capital F of x is 0.6. Then 3 to 4, in between 3 and 4, the function is again constant. At x equal to 4, the function changes. At x equal to 4, the function is 0.8. Then in between 4 to 5, the function is constant. And exactly at point x equal to 5, the function changes. At x equal to 5, capital F of x is equal to 1. This point. Then if x is greater than 5, then the function is constant. Okay. Then if we observe this graph of CDF, this looks like the steps. This function have a gems at x equal to xi. This is gems. So this capital F of x is called as the step function. This graph is look like steps, therefore the function is called as the step function. Okay. Now we see properties of distribution function. There are some important properties of distribution function. Properties of distribution function. Properties of distribution function. Following are the some properties of distribution function. First property is capital F of x is defined for all x belongs to capital R. R is the real line. R is the real line. This is the first property. Then second property is capital F of x lies between 0 and 1, since it is probability of an event. Therefore, distribution function lies between 0 and 1. Then property number 3, it is a step function. It is a step function. It is clear from this graph of the CDF. The function in between two values of the random variable x is constant, and at x equal to xi, the function have a jump, so it is called as the step function. Then next property is it is non-decreasing function of x. It is non-decreasing function of x, that is if a is less than b, then if a is less than b, then capital F of a is less than capital F of b. Therefore, the function is called as the non-decreasing function. Property number 5. Capital F of minus infinity equal to 0 and capital F of plus infinity equal to 1. That is, capital F of minus infinity equal to limit x tends to minus infinity of capital F of x and capital F of plus infinity equal to limit x tends to infinity of capital F of x. Means the function capital F of x is 0 if x is less than 1 and if x is greater than 5, then the value of the capital F of x is 1. If x is greater than or equal to 5, then the capital F of x is equal to 1. Therefore, the f of minus infinity is equal to 0 and f of plus infinity is equal to 1. These are the some important properties of the distribution function or cumulative distribution function. Then now we see the how to find median of probability distribution. If we have a given probability distribution, and for that probability distribution, how to find value of median. Median of probability distribution. See definition. Let capital X be a discrete random variable with CDF capital F of x, then median M of probability, median of probability distribution of x, distribution of x is defined as probability of x is less than or equal to m, which is greater than or equal to 1/2, or probability of x is greater than or equal to m, which is greater than or equal to 1/2. That is, suppose we have a probability distribution x. This random variable takes values 1, 2, 3, 4 and 5, and their corresponding probabilities are 0.2, 0.3, 0.15, then 0.15 and 0.2. This is the probability distribution. Now for this probability distribution, first we obtain the distribution function, that is capital F of x. At x equal to 1, p of x is 0.2, therefore capital F of x is 0.2. At x equal to 2, CDF is 0.5, then here is 0.65, then 0.8 and 1. Then by definition of median is the value of the random variable at which distribution function is greater than or equal to 1/2. Here at x equal to 2, the value of distribution function is 0.5. Therefore, the median of random variable x is 2. Here is median value is 2. That is, here probability of x is less than or equal to 2, which is equal to 0.5. That is, probability of x equal to 1 plus probability of x equal to 2, which is equal to 0.5. Therefore median m is equal to 2. Median value is 2. In this way we can compute the or obtain the median of the given probability distribution. Then mode of the probability distribution, we have to find out the mode value of the probability distribution. Mode, let capital X be a discrete random variable with PMF P of x. Then mode M0 of probability distribution. Mode of the probability distribution is the value of random variable x corresponding to maximum probability Okay, for example, suppose the random variable x takes values 5, 10, 15, 20 and 25. Their corresponding probabilities are 0.13, 0.15, 0.24, 0.37 and lastly 0.11. This is the probability distribution. For this probability distribution, we have to find out the value of mode. By definition of mode is the value of random variable corresponding to the maximum probability. If we observe this probability distribution, here maximum probability is 0.37 and this probability is corresponding to the value of random variable which is equal to 20. Therefore, 20 is the mode of the given probability distribution. Therefore, mode is equal to M0 which is equal to 20. In this way, we can compute the mode value of the given probability distribution. Then next one is probability distribution of a function of discrete random variable. Probability distribution of a function of discrete random variable. Let capital X be a discrete random variable with the following probability distribution. With the following probability distribution. This capital X is the discrete random variable. Takes values x1, x2, so on, xi, again so on, xn, with corresponding probabilities are p of x, p1, p2, pi and pn. Suppose y equal to g of x. Y equal to g of x is a real valued function of x. Y equal to g of x is a real valued function of x. Then y takes values. Y1 equal to g of x1, y2 equal to g of x2, So yi is equal to g of xi and yn is equal to g of xn. These are the possible values of the random variable x. Now the probability distribution of random variable x is as probability distribution of random variable y is, the random variable y takes values y1, y2, yi, yn with corresponding probabilities p1, p2, pi and pn. This is the probability distribution of a function of discrete random variable. Means if we have a probability distribution of random variable x, then suppose y is the real valued function of x, that is y is equal to g of x, then the possible values of y are y1, y2, yn. Then we have to find out the probability distribution of random variable y. These are the possible values of random variable y, y1, y2, yi, yn, and corresponding probabilities are p1, p2, pi, pn. Here in this case the values of the random variable y only changes, but the probabilities of random variable y as it is the probabilities of the random variable x, means there is only change in values of the random variable x but not in the probabilities. So it is called as the probability distribution of a discrete random variable, probability distribution of a function of discrete random variable. Thank you.